Okay, so we define this sequence of random variables x tilde k, and then we said that we are interested in this process n tilde t. But what is this process? What does it mean? So let's try to understand that first, and then we'll see the connection with these random variables. So note that this t naught is something fixed. Okay, it's a fixed positive real number. And then for every t bigger than or equal to 0, n tilde t, which is n of t naught plus t minus n of t naught, is basically the number of phone calls arriving in this semi-open interval t naught to t naught plus t. Okay? In other words, what this means is the following. Suppose you work in the telephone exchange, but you don't join at the time 0. So you don't join at the beginning of the office hour. You join at time t naught. And then the moment you join, you reset your clock and make it 0. Okay? Then n tilde t counts the number of phone calls arriving up to time t according to this new clock of yours. Okay? We'll actually show that n tilde t is also a homogeneous Poisson process, and its rate is going to be alpha. Okay? And this is essentially a manifestation of lack of memory property of exponential distribution. It makes the homogeneous Poisson process forget that you joined office at time t naught. So in order to understand this, we can take another example. Say, buses arrive in a bus stop according to a Poisson process with intensity alpha. Okay? Now you go to the bus stop at some point, say t naught. For you, of course, your clock starts right then, the moment you go to the bus stop. Even though you went to the bus stop at time t naught, not at time 0, still the process of arrival of buses for you would still be a Poisson process, homogeneous Poisson process with intensity alpha. So this is a manifestation of lack of memory property, as I said. Now let's start with an easy observation. First, note that S of n t naught plus 1 is the arrival time of the first phone call strictly after time t naught. Okay? That's because S of n t naught was the last phone call before time t naught. So therefore, S of n t naught plus 1 is the arrival time of the first phone call after time t naught. Now we obviously have fixed a t naught, but I'll just remind you that we have fixed a t naught. Now we are trying to see when is n tilde t going to be 0. Note that n tilde t is just n of t naught plus t minus n of t naught, which is the number of phone calls in the interval t naught to t naught plus t. T naught is not included in the interval, but t naught plus t is included. So this is same as saying n of t naught plus t is equal to n of t naught. So in other words, between the time t naught and t naught plus t, no arrival has happened. Now I'm going to write it down in terms of these random variables. Those are here. So this means the first phone call after time t naught. So at time t naught, the number of phone calls is equal to the number of phone calls at time t naught plus t. So this means the first phone call after time t naught definitely arrives after time t naught plus t. Okay? This is the only way the number of phone calls up to time t naught and the number of phone calls up to t naught plus t can be equal. Okay? This means, what is the first phone call after time t naught? That's precisely S of n t naught plus 1. So therefore, this is same as saying n of n t naught plus 1 is strictly bigger than t naught plus t. So let's take t naught on the other side. So this is same as saying S of n t naught plus 1 minus t naught is strictly bigger than t. wait, what is this guy? This guy is nothing but x1 tilde. This is exactly what we called x1 tilde, as we see from the picture. So therefore, this is same as saying x1 tilde is bigger than t. So what we have observed is that n tilde t is equal to 0 if and only if x1 tilde is bigger than t. So now we see the connection between this n tilde t and the sequence of random variables that we have defined. We only see the connection so far with the x1 tilde, but we will soon see the connection with other x tildes. Okay. So with this observation, let's move on to the next one, the next observation. Again, we always fix a t naught. Now we also fix a k, which is a positive integer. Now this is the picture. Now note that after time t naught, s of n t naught plus 1 is the arrival time of the first phone call after time t naught. This guy is the arrival time of the second phone call. This guy, s of n t naught plus 3, is the arrival time of the third phone call after t naught, and so on. Okay. So more generally, s of n t naught plus k is the arrival time of the kth phone call after time t naught. When I say after, I always mean strictly after. Okay. Doesn't matter, but it's good to always, because everything is a continuous random variable here, but it's good to fix a convention. Okay. Also note that, say s of n t naught plus 3. In this picture, it's clear. What is s of n t naught plus 3? After t naught, you just have to have x1 tilde, then x2 tilde plus x3 tilde. So therefore, s of n t naught plus 3 is t naught plus x1 tilde plus x2 tilde plus x3 tilde. So more generally, s of n t naught plus k is t naught plus x1 tilde plus x2 tilde all the way up to xk tilde. Okay. Now we can make the next observation. What is that? N tilde t, which is the n of t naught plus t minus n t naught, is equal to k if and only if. So this means, so this counts the number of phone calls in the interval t naught to t naught plus t, this semi-open interval, right? So this just means, this event just means exactly k phone calls arrive in the time interval t naught to t naught plus t. Which means, so exactly k phone calls arrive in this interval means the kth phone call after time t naught must have happened before time t naught plus t, and the k plus 1th phone call after time t naught must happen after t naught plus t. Okay. So kth phone call after time t naught is this guy. So s of n t naught plus k has to be less than or equal to t naught plus t, and the k plus 1th phone call after time t naught, which is s of n t naught plus k plus 1, this has to be strictly bigger than t naught plus t. Okay. So these two things are equivalent. This will happen if and only if this will happen. That's clear. Now we'll write everything in terms of this x1 tilde and so on. We observe that s of n t naught plus k is just t naught plus x1 tilde plus x2 tilde all the way up to xk tilde. So let's use it. So therefore this statement is same as saying t plus x1 tilde plus x2 tilde all the way up to xk tilde is less than or equal to t naught plus t, which in turn is strictly less than t naught plus x1 tilde plus x2 tilde all the way up to xk minus 1, xk plus 1 tilde. Okay. Of course, t naught will get cancelled from all of these. So we'll get that this is if and only if the sum of first kx tildes is less than or equal to t, which in turn is strictly less than the sum of first k plus 1 x tildes. Okay. So if you define sk tilde to be the sum of first xk tildes, first kx tildes, sorry. Okay. So in other words, x tilde k is x1 tilde plus x2 tilde all the way up to xk tilde for all positive integer k, then this statement is same as saying sk tilde is less than or equal to t and sk plus 1 tilde is strictly bigger than t. Note that in order to keep parity with what we have done before, we'll define s tilde 0 equal to 0. identically equal to 0. Okay. So in other words, sk tilde is a random variable which takes the value 0 with probability 1. Okay. Now, let's just go back to the previous observation where we observe that n tilde t is equal to 0 if and only if x1 tilde is bigger than k, strictly bigger than t. Okay. So n tilde t is equal to 0 if and only if x1 tilde is bigger than t. In the previous observation, we observed that if n tilde t is equal to k for any positive integer k, if and only if s tilde k is less than or equal to t and s tilde k plus 1 is strictly bigger than t. Now, observe that this statement is same as saying t is bigger than or equal to s0 tilde and t is less than s1 tilde. Why? Because s0 tilde, we have defined it in the previous slide. If you go back, we have defined it to be the 0 random variable. So therefore, trivially, this statement holds because t is bigger than or equal to 0. And because of that, because x1 tilde and s1 tilde is also they are also equal. Okay. So therefore, s1 tilde is strictly bigger than t. So therefore, these two statements are actually equivalent. But what's the point I'm trying to make here? The point I'm trying to make is observation. This particular observation that we made in this slide is also true for k equal to 0. If you put k equal to 0, okay, this we observe for k strictly bigger than 0, a positive integer, in other words, but it's also true for k equal to 0 because s tilde 0 is 0 and then s tilde 1 is just x1. Okay? So therefore, this statement that we had in the previous slide is also true for k equal to 0. That's the point I'm trying to make.